Yes, thank you guys. We are here again. Okay, this is indices part 5. Okay, we want to conclude the final part for indices, which is exponential functions. Um, we thank you for your likes, for your share, for your comments. Okay, and we are moving forward. So this is exponential functions. Under exponential functions, you need to note some things. Okay, for exponential, there must be an equal sign. Equal sign is common everywhere. Like, equation. When they say equal, equation, they pick equal from equation. You understand? Equal sign must be there. So that's the first condition. The second condition is the unknown can be the power or the index. We all know that power is the same thing as index, and I've mentioned that over and over again. Then the third is very simple, it's straightforward. The unknown can be the base sometimes. So it can be the base. They can tell you that, okay, find the value of x, and the x is in form of base, is a base position. Okay, and in part one of indices, I've mentioned what we mean by base and power. So then in the last option, both sides of the equation must either have the same base, okay, to get the unknown. Okay, now if they have the same base, it means the unknown must be the power. It's just vice versa. And if they have the same power, it means to get the unknown is going to be the what? The base. It's very simple. We'll self questions on that based on that. You understand? Like I said, that let me reiterate that because of this is what we call, this is the base. Okay. This S here is what we call power or index. So I just needed to reiterate this because of the statement that I have here. There must be equal sign. This is the equal sign here. So you can see this is equal sign. So it's obeying it, equal sign. Okay. So the unknown can be the power. What is the power here? The power is x, which is the unknown. X, we don't know. They can actually find x, solve for x. Okay. Now, the unknown can be the base sometimes. Okay. But in this case, it's not the base because the base has value, which is 25, which is 0.25 and what? 16, which is decimal. And don't forget, this is what we just finished in part 4 right now. Okay. So we just concluded this in part 4, which is you need to convert it to proper fraction. So now they said both sides of the equation must either have the same base to get the unknown. What they are saying is that what you have on the left hand side as the base must also be the same thing on what you have on the right hand side as the base. Then you can now cancel out. Very important. Under this part, because these are the questions you'll be seeing under your theoretical part, okay? And most times you can also see it in objective, okay? Before you can get the unknown, which is the power, under this question, okay? The base here must be the same thing as the base here. The base here must be the same thing as the what? The base here. Then you can now do what? You can now cancel, okay? In this case too, the base here must be the same thing as the base here. The same thing applies here. Okay, let's solve one question now so that we can you can understand what I'm trying to say. So for number one here, is saying that we have 0.25, okay, raised per x equals what? 16. Now, don't forget decimal in part 4, indices, part 4, decimal base. Convert it to what? Proper fraction. I moved this point 2 times. So it's same thing as saying 25 over 100 all over what? X equals 16. Okay, I've converted it to proper fraction. Okay, now 25 can go here 1, 25 can go here 4. This is the same thing as saying 1 over 4 all raised to power x equals what? 16. It's as simple as that. Don't forget, in the law of indices, 1 over 4 is the same thing as saying 1 over 4 is the same thing as saying 4 raised to power minus 1 all raised to power x equals 16. I mentioned it in part 4 too. Okay, I mentioned it in part 4 that, okay, that if you have 1 over 4, a value raised to power minus something is the same thing as 1 over, okay, that is part of the law, negative power, part of the law in indices. I mentioned in part 1 and part 2. Please, if you've not gone through it, go through it so that you can understand what I'm saying. Look at this one here. Minus 1 times x is the same thing as saying minus x. Okay, 1 times x is x. I've told you anything times 1 is that thing. Okay, this is minus 1 raised to power what? That's equals what? 16. Now look at this very well. 4 times 4 can give me 16. I'm working towards this. I'm working towards this. Don't forget the law. I'm working towards this. Both sides of the equation must either have the same base. I know that I can change this to the same base. 4 times 4 will give me 16. Okay? That's what I'm working towards so that I can cancel now. So this one is the same thing as 4 raised to power minus s equals 4 raised to power what? 2. 4 raised to power 2 is the same thing as saying 4 times 4. That's what? 6. Okay, so then it means that, now look at it very well. For condition 3, both sides of the equation must either have the same base to get. So now look at it now. This is my base here. Okay, look at the base here. So it means it's what? The same base. So what is the unknown here? Look at it now. What is the unknown here? What is the unknown here? Look at it. That is my what? This is my power. Power is unknown. So that is, it means that you can see what I'm saying here. 4 here, the same base. It means 4 we cancel 4. Then you drop the power. This is what? That implies that minus s equals what? 2. And x equals what? Minus 2. It's as simple as that. If I say find x, that is what we have in this thing. So at the end of the day, it means that the x is what? We've solved number 1. Okay, for number 2 now. Number 2 is saying that we have 2 raised to power x equals what? 64. You can see that this one is very, very straightforward. So what you can now do is that, how can I make this 64 this base? Okay, it means that I can multiply 2 in 5 or 6 places to give me 64. So this is something as saying 2x equals what? 2 times 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, that's what? 64. All this is raised to power 1, 1, 1, 1. Indices. Don't forget indices, multiplication law under indices. Pick one base and have the power. So this is the same thing as saying 2x equals 2 raised to power what? 1 plus 1 plus 1 plus 1 plus 1. 1, 2, 3, 4, 5 plus 1. Okay, that is indices. So if you've not gone through part 1 of indices, please go through it. It's as simple as that. 2 raised to power is same thing as what? 2 raised to power what? 5. 2 raised to power what? 6. Okay, because this is 6. 1, 2, 3, 4, 5, 6. So it means that base 2 can cancel what? Base 2. That is condition 3. Condition 3, both sides of the equation, this is equal sign, equation, equal sign, must either have the same base, this is the same base, to get the unknown. What is the unknown we are looking for, which is the power? So what you now say is that this implies that x is equal to 6. You can see that this thing is just like chinchi and what? And pure water. Look at number 3 here. Number 3, 4 raised to power x minus what? 32 equals what? 0. They are just joking here. They're just playing with you moving negative sign across equal sign. Okay, so it means that I can move this minus. I've told you in indices, under indices of factorization, I said any value on the right hand side is the owner of this sign. So now this minus here, 32 is the owner. So it's moving across, it's jumping equal sign. If it's jumping equal sign, it means that it's changing to positive, which is something as what? 32. Okay, it's looking like normal exponential function now. So this one is something as saying 4x equals 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Okay, so now 1, 1, 1, 1, 1. I've told you anything raised to power 1 is that thing. So we always have 1 on top of this, but we know it's still the same 32. So this is something as saying 4x indices, law of indices, 1 plus 1 plus 1 plus 1, 1, 2, 3, 4 plus 1. So it's same thing as 4s raised to power what? 2 raised to power what? 5. Okay. Now don't forget, this 2 is different from 4. I can still simplify this. This is the same thing as what saying what? 2 times 2. Okay. Raised to power x is equals 2 raised to power 5. This is 1, this is 1. Okay. Indices, multiplication law. Pick one base, add the power, 1 plus 1. Okay, raised to power x equals 2 raised to power 5. So this is 2 raised to power 2, x equals 2 raised to power 5. Okay, 2 times x will give us what? 2 raised to power 2x, which is equals to 2 raised to power 5. So it means they now have the same base. cancel, cancel, bring down the power. That implies 2x equals what? 5. X equals 5 over 2. That is when you divide both sides by 2. You divide this place by 2, you divide this place by 2. So 2, if you divide this place by 2, 2 will cancel 2 here. Then you now have, that implies that you now have x equals, that's the value of x. So if they say find x, don't be scared. Don't be looking for x. X is in the question, but you can get the value of x. That's what they mean by find the value of x. You understand? So at the end of the day, the answer is what? X equals 5 over 2. So like I've said, please continue to like, continue to share, continue to comment, because we need to reach a lot of students having challenges with mathematics for them to see that mathematics is simple. It's like chin chin and pure water, and it's very, very interesting. Okay. All what they just need is that we are taking this mathematics to them to solve it, because they just need a smartphone and an internet for them to solve mathematics at their comfort zone. Thank you very much, and God bless you.